Welcome to this session on averages. Averages is a very important topic, and there are two ways we solve questions on averages. So I'll start with an example and we'll be able to understand then how those two methods can be adopted. So the first question reads like there are 20 girls and 30 boys in a class, and their respective average marks are found to be 55 and 58. The average marks of the entire class is, that's what we want to calculate. So there are two groups. The first group is girls, which are 20 in number, and then there's another group called boys, which are 30 in number, right? So I'll adopt the first strategy in this case. The first strategy is where we calculate the sum. So 55 is the average in the case of girls, so the total adds out to be around 1100 or 1100. When we talk about the boys, the average marks they get is 58, and in this case the number comes out to be 1740, right? So when we take these two numbers come up, one way is we add those numbers and we get a sum is 2840. And as we know, 20 plus 30, that's the total number of students is 50. So we get the average of this, and that comes out to be 56.8. So that is the answer. That is one way where we are summing up the numbers and coming to a total, and then we are dividing it by the total number of students. Now there's another approach to it. Whenever we talk or solve questions of averages, we have to understand one thing. See, one number is 55 and the other is 58, right? So in such a scenario, the average would always fall between these two. And whenever it falls between these two numbers, it will be in the ratio of something which the numbers stand. So there's 20 here and 30 here. So total is 50. So if I take and as a simple as a 5 and I divide this into 5 parts, right? So this is how I've divided. So when I divide this whole segment, that is the difference between 55 and 58, that are the two numbers between which we have to calculate an average, and I've come out 5 parts because these two can come into the ratio of 2:3. So basically I'm taking the ratio as 2:3. So I'm dividing it into, as 2 ratio and 3 ratio would be 5. So I'm dividing this into 5 parts. Now what if I divide by 5 parts? So the difference, that is 58 minus 55, is equal to 3. So if this difference 3 is divided by 5, each interval will come out to be 0.6. So if I write down something like 55.6 here, 56.2, 56.8, then 57.4. So these are the after every interval that we receive. Now because the ratio is 2:3, so there will be more pressure on this side and lesser on this part. So it is something like from this, how far it has to come? 3 times spaces, and this has to come 2. So for this, it will be 1, 2, and 3. That's 56.28, 56.8. And from here, it has to come 2 spaces, that is 1 and 2, comes out to be 56.8. So either way you calculate, you end up getting answer of 56.8. I'll explain this a bit more in detail. So basically what we're trying to do in this case is, we are trying to explain something, how averages work. Average means, that is what is coming out to be the number in between the two extremes. So when we have two extremes, suppose one number is 40, another is 60, there's a group of students. Let's take another example where girls weigh 60 kgs, whereas girls weigh 40 kgs and boys weigh 60 kgs on an average. If all of them are put together, what would be the weight? So how would you calculate that? See, when one group is weighing 40 as an average, another group is weighing 60 as an average, when they put together, they cannot go beyond 60 or below 40. So it has to be within this range. Now, how do we determine what number it will be within this range? One thing we are sure that this will be within this range of 40 to 60. Any average in any proportion of 40 and 60 will fall between 40 and 60 only. It cannot go beyond the either of the extremes, right? So in such a scenario, how do we calculate what the number is? We identify the ratios of the weights of 40 and 60. Like we did here, that is 2:3 we identified because there were 20 students and 30 students, which boils down to 2:3, and thus we get 5 as a total intervals. So we divide that gap into 5 parts. Now what happens is, if I say there is more students in the 40 category or 60 category, the one which has more students, so if there are 20 students here, they have less weightage than the 30 students here. So obviously their bent would be towards the 60 because there are more students on this side. Had it been 30 students on this side and 20 students on this side, the weightage would have gone here and it would have shifted the tilt towards the this. So similarly, if I take the earlier example of 55 and 58, let's understand that. So here we had 55 and here we had 58, and in this we said that 20 are girls, 30 are boys, and the average wage was this. So now because it's coming out as 2:3 and we divide it into 5 parts, 1 2 3 lines, so we get 1 2 3 4 then 5. Now basically we have to divide this into this 3 by 5 and we get 0.6 as the interval. So thus we put the numbers as 55.6, 56.2, 56.8, and then 57.4, right? And then 58 eventually. Now, because it was 2:3 ratio, had it been 3:2 ratio, suppose there were 30 girls and 20 boys with the same averages, then the weight, it gets transferred like this. So the heavier parts takes more weightage. So it would have been 3 parts here, 3 ratio here, 2 here. So 3 parts will be away from this, 2 will be away from this. So it will be more close and the answer would have been 56.2 had the ratio been 3:2 or 30 girls, 20 boys. But it was not so, thus it was 56.8. This could have been 10 girls and 40 boys. In such a scenario, it would have been 1 here, 4 here, 4 away from this, 1 away from this. It would have gone something very close. So with more weightage, it would have gone closer to 58. Had it been 40 girls and 10 boys, then it would have shifted the weight to this part. So basically what is happening is, in this scenario is, we are trying to explain that whenever we calculate averages, we have to be between the extremes A and B, and first we divide it into various parts based on the ratio of the numbers, and then we identify whichever has more weightage, it will move towards, tilt towards that favor. Suppose A has more weightage, then it will be more closer to this. If B has more weightage, it will be more closer to somewhere like this. So that is the how average is done. That is the another way. So there are two ways. One is called the weightage we calculate as explained, and another is called you calculate by sum total. So two ways you can solve the weightage question, right? So let's move forward and try to solve another question. So let's take another question, and it says the average age of teacher and 3 students is 20 years, right? So average age of a teacher is say T and 3 students is 20. So there are 3 students and the average age is 20. Now this is sum total, and when we take divided by the equal number of the number of persons, we get the average. So T plus 3S, T stands for teachers, S stands for students, divided by 4 we get 20. So we get basically T plus 3S is equal to 80, right? Now it says if all the 3 students are of the same age and the difference between the age of the teacher and each student is 20 years, so T minus S is equal to 20. That's the second equation. We just basically subtract this one from this equation, we get this, and then we get this, right? So basically what we're ending up getting is that 4S is equal to 60, S is equal to 15. So a child is aged 15, so the teacher will be T plus, as T minus S is equal to 20. We know this is 15. So what this would be 35. So T is basically 35, S is basically 15. From this we know that the teacher is 35, and we can recheck that if they add up 3S, if I add, that is equal to 3 into 15 is equal to 45, is 35 plus 45 is 80. So we confirm that answer. So what is the age of the teacher? It's 35 years of age, right? Now let's solve another question on this. So it says a sum of rupees 2500 is distributed between X, Y, and Z in the ratio of 1:2, 3:4, 5:6. Okay, so these, if you see, this is around 50%, this is around what, 75%, and this is around what, around 83%. So obviously these three don't add up to be 100%. No, it's more than that. So let's take an LCM of these. So 1/2 plus 3/4 plus 5/6, and we take a least common multiple, comes out to be 12, and we get 6 plus we get 9, and then we get 10. So basically we're getting is 25/12 of X is equal to 2500. That's the rupees. X comes out to be what, 1200. So basically what are the three ratios then we're getting? Taking this as 1200, the ratios comes out to be 1/2 of this would be 600, 3/4 would be what, 900, and 5/6 would be what, 1000. And it's saying difference between the maximum share and the minimum share. So minimum share, maximum share difference is 400. That's the answer. So basically what we did, we identified the ratios, we realized that these ratios don't add up to be 100%, so there's more than 100%. So we added all of three by taking an LCM. So we started with ratios, we moved identifying not 100%, adding to be. So we did what? We took an LCM and we calculated X, and based on this X we came out with the values, and once we came out with the values we identified the difference. So it was a simple step-by-step we followed. Now let's look at another question. Suppose now this is very similar to what we were discussing earlier to some extent, I would say, but not completely. The average score of a batsman after 50th innings, so he's played 50 innings, is 46.4. Okay, so one way which would be easier way in this case would be the sum total way. Why it would be, I'll explain that also. In this we just multiply and we get is 2320 as the sum total. So by 50th innings he has already scored these many runs. After 60th innings his average has score increases by 22.6. So now it was 46.4 plus 2.6, so it adds up to be what, 49. So after 60 innings it would be 60 into 49, that equals to what, 2940. Earlier we had 2320. What is the difference? 620. How many innings? 60 minus 50, that is 10. So 620 by 10 comes out to be 62. So now this is the answer. This is the sum total way of solving. Easier way. Let's also try it with the other method called what we call as the method of weightage. Now let's solve also with weightage. So earlier it was 46.4. That is one part. Yes. Now another part has come out to be 49. So earlier average was up till 50th innings. So 50 weight is here. It comes out to be this. Then 49 is the new, right? So the gap is 2.6. I've just known that. Now I have to identify this extreme. How would I do that? I know this is 10. Now important part is that we have to understand that this number 2.6, because the weightage is coming 5, so it is 5:1, right? Now what has happened is the ratio total parts will be 6, so one part will be 2.6, then the 5 parts would be 2.6 into 5, because this gap 1 is this, 5 is this. So basically We are doing it like this, right? So it comes out to be 13. Now you add 13 to this 49, and what you get is 62. So you got the answer here. So basically, the weightage also works here because I know the first extreme, I know the mid, that is 49. I want to know the extreme, the other extreme, and I know it's 5:1 ratio, the weightage. So 1 will be this side, 5 will go this side. Okay, so this is 2.6. I need to do a 5, multiply it by 5 and get 2.6 into 5 is equal to 13, and so I add up and get to 62. So this is how basically you can solve this average question by weightage method. So there are two methods as we have understood. One is called the sum total, where you add up the numbers, and the other is called the weightage method, where you try to find the ratios. So either way, whichever you're comfortable, you can solve the question. It depends on what kind of a question has come. Usually sum total is a good method, but it requires multiplication. Whereas once you get a grip of the weightage method, it becomes much more easier to solve the questions with weightage method.